Hello everybody, in this video I will discuss the empirical rule and how to use it to solve application problems. Okay, so what does the empirical rule tell us? It says that if we have a distribution that's approximately symmetric or bell-shaped and looks something like this, then we can say certain things. For example, 68% of the data lives within one standard deviation of the mean. Okay? And then 95% of the data lives within 2 standard deviations of the mean, while almost all of it, 99.7%, lives within 3 standard deviations of the mean. Now we can actually say a little bit more if we consider the middle data over here, these two pieces. We know that the distribution is symmetric, which means this piece right here should be equal to this piece right here. Okay, now since we have 68%, 68 divided by 2, that's 34. So what can we say? We can say that roughly 34% of the data is one standard deviation above the mean. Okay, and roughly 34% of the data is one standard deviation below the mean. Okay, now we can do a similar analysis to the other two pieces. Let's take a look at this one here. Should be equal to this one over here since the distribution is symmetric. Okay, so how do we do this one? Now remember, within 2 standard deviations of the mean we have 95% of the data. So if this is 95, the whole thing, then we can do the following. 95 minus 64, that's this middle part, divide by 2. This will give us the percentage of each of these green pieces. So what do we get? 95 minus 64 divide, should be 68, my bad. Divide by 2, we should get 13.5%. Okay, so 13.5% goes here, 13.5% goes here. Alright, then similarly we can compute the percentage over here and here. Since this whole big piece is 99.7%, you can do 99.7 minus 95 divide by 2 to get each of those, and you should get 2.35% and 2.35% here. Okay, now let's see, what about these two pieces right here on the edges? What do we do about those? There's a couple of different things you can do. You can say, okay, the whole thing should be 100%, so you can do 100 minus 99.7 divided by 2, or you can take a look at the half of the distribution and say, wait a minute, that is 50%. So 50 minus 34 minus 13.5 minus 2.35, this piece right here and that one. So let me go ahead and write it out. Okay, I'm going to do 50% minus 34 minus 13.5 minus 2.35. You should get a very small percentage. So this one should be 0.15% and 0.15% here. Okay, so this picture is a little bit more detailed than usually is given, but it's not difficult to calculate. Okay, so how would we apply this to solve a problem? Okay, let's take a look at this one. Suppose the monthly cell phone bills for Maryland college students have a bell-shaped distribution with a mean of $82 and a standard deviation of $12. The first part of this problem is asking to make an appropriate picture representing this information. Alright, so what would I do? Well, I'm going to use my model to solve this application problem. So what would I do? The first thing that I would do is make a bell-shaped distribution like this, but now in the mean I'm going to put my actual number. Okay, what do we have here? $82 for the mean. So $82 is going to go right in the middle, and then I'm going to split my bell-shaped curve into pieces here. 3 standard deviations above the mean and 3 standard deviations below the mean. And now I'm going to label this according to my data. We have standard deviation of $12, so 82 plus 12, 94. 94 plus 12, that's 106. And then plus another 12, we'll get 118. Okay, going the other way, we do 82 minus 12, that's 70. 70 minus 12, that is 58. And 58 minus 12 is 46. Okay, so this picture tells me what? Well, about 68% of Maryland college students pay somewhere between $70 and $94 for their cell phone. About 95% of those students pay somewhere between $58 and $106. And then almost all of them, 99.7, pay somewhere between $46 and $118. Okay, and only a small percentage, so what was it, 0.15%, pays over $118, and also a very small percentage of students pays under $46 for their cell phone bill. Okay, so that was part A. Now I can actually answer a couple of questions. Let's see what they're asking us here. This one says, what percentage of Maryland students have a cell phone bill of at least $94? Okay, at least $94. What does that mean? At least means 94 or higher, right? So this would be all of these students over here. Okay, at least $94. At least $94 for their cell phone bill. So what do we do here? Now we already know what those pieces are. So if I go up here just to check, okay, I have 13.5, 2.35, and 0.15. I can add them all up. Okay. So 13.5 plus 2.35 plus 0.15. If I do this, I'm going to get 16%. Okay? So this piece right here says that roughly 16% of all Maryland college students pay over $94 for their cell phone bill. Okay? Let's see what else they're asking us. What percentage of Maryland students have a cell phone bill below $58? Alright, let's go back to our picture. Below $58, what would that be? Okay, below $58 is this piece right here. Again, I can go ahead and take a look at my cheat sheet. It's 0.15 and 2.35. So I can say that below $58, we have only 2.5% of all students have a cell phone this low. Cell phone bill this low. Okay? And let's see, what else is this problem asking us to do? Christine is a student at Salisbury University and her cell phone bill is in the 84th percentile. How much does she pay for her cell phone bill? Okay, let's take a look at what we got here. 84th percentile. Now, you might be tempted to solve this problem by trying to compute the percentile, but you actually don't need to do this. Let's just think about it. Okay, this median, right, or the mean and median for the symmetric distribution is the same. This part right here, what does this represent? This is the 50th percentile, right? Half of the data lives below and half of the data lives above. Okay, now if this was 34%, then this value right here represents 50 plus 34. That is 84th percentile. Alright, so the answer is she has to pay $94 for her cell phone bill. Okay, this is it. Thank you for watching.